All right, moving on. 27 right here. We've got square root of b to the fourth over 25. That's all in the root equals 4. So that's the same as writing b to the fourth in its own root times or divided by root 25 equals 4. So we could say that b squared over 5 equals 4, which means that b squared equals 20, because we just multiply both sides by 5. And we take the square root of both sides, and we end up with b equals, square root of 20 is 4 times 5, so it's 2 root 5. Oh yeah, and is it plus or minus? Yes, because if this was negative, we would get 20 when we squared it, and if it was positive, we would get 20, so it's plus or minus. Okay, moving on, 28. Root 2x plus 3 equals root 6x minus 1. Well, this looks pretty easy if we just square both sides right off the bat. Bam. We end up with 2x plus 3 equals 6x minus 1. There's no squared variables even. Seems super easy. Minus 2x from both sides. We end up with 3 equals 4x minus 1. We're going to add 1 to both sides, get 4 equals 4x. Divide both sides by 4, and we're going to get x equals 1. Now we're going to try to plug it back in. 2 plus 3 is 5, so root 5, does that equal 6 minus 1, root 5? Certainly it does. That is the answer. Easy. Moving on, 29. The time t in seconds for the pendulum of a large clock to make one swing is given by this equation. And the top thing is L. I'll use capital because my lowercase looks like a 1. Where L is the length of the pendulum in feet, if one swing takes 4 seconds, that means we replace the t with 4 because that's what the t represents. How long is the pendulum? So we're looking for L. So if we get rid of that 2 first by division, so we get 2 equals root L over 3.3, and then we can get rid of the square root by squaring both sides. So now we get 4 equals L over 3.3, and then we multiply both sides by 3.3, which is going to be 12 something, 13.2, is that right? 13.2. Okay, so we know the length is 13.2, rereading for units. Pendulum in feet, so 13.2 feet, done. Number 30. State the domain of each function, then graph it. Okay, 30, y equals root 2x plus 6. Well, the domain means that the square root has to be greater than or equal to 0. So 2x is greater than or equal to negative 6. X is greater than or equal to negative 3. So anything less than negative 3, we do not need to graph. Okay, so let me pull a graph out here. My content graph. How about this? Okay. Done. Get out of here. Okay. Let's do this. Let's move this off to the side for a moment. That didn't work. How about over here? Okay. Now let's surround this. Let's kind of move it. There we go. Right over there. All right. So how am I going to make this work? If let's say x is negative 3. Let's just start at the lowest possible thing we can do. If x is negative 3, then we get negative 6 plus 6, which is 0, so negative 3 comma 0. Bam. Done. Let's see. How am I going to make this equal to like 1 and 4 square numbers? I could just set it equal to that, or I could just kind of ballpark some stuff here. So let's try 0. If x is 0, then we get square root of 6. Well, square root of 6 is, it's more than 2, but it's less than 3, so maybe 2 point something, which won't really show up in the graph anyway, so we could just say kind of like here. And let's try something like, I don't know, 4. kind of arbitrary. 4 times 2 is 8, plus 6 is 14. Well, the square root of 16 is 4, so it's a little less than 4. So, 3 point something, 8 maybe. 1, 2, 3, 4, 1, 2, 3, so a little less. Okay, yeah, let's go a little bigger. So how about, like, I don't know, 10. 10 is 26. Ooh, that's really close to 5, right? So almost 5. So 10, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. And that looks pretty reasonable based on the graphs we've seen that have square roots in them. There we go, bam. 30 is done. 31. We have y is equal to the square root of x minus 7. Now the domain, all we care about is what's under the root, so we know that x has to be greater than or equal to 0. So let's get our graph. Whoops, don't do that. Let's move this. And let's get x, y. So let's say x is 0. So then we get y equals square root of 0 minus 7, which is negative 7. 1, 2, 3, 4, 5, 6, 7. Start way down here. And now we can choose numbers much easier. So the square root of 1 is 1. So 1 minus 7 is negative 6. Square root of 4 is 2, so negative 5. Square root of 9 is 3, so negative 4. You get the idea. So we're going to use 0, negative 7, 1, negative 6 is here, 4, negative, 4, negative 5, so 4 right there, 9, negative 4, so 4, 5, 6, 7, 8, 9, there we go. And that looks, again, like a reasonable square root graph. It looks like the parent function is just slid down 7 units, which is what that does. Sounds good to me. Number 32. Y equals square root of x minus 4. So again, this is the parent function shifted 4 units to the right. But if you don't know that, you could still graph it, no big deal. So we know that x has to be greater, nope, almost messed up there. X minus 4 has to be greater than or equal to 0. So we know that x is greater than or equal to 4. So everything we graph can start with 4. And pulling out the graph. Bam. Get rid of that. Okay. So if we plug in 4 here, we get 0. We know the square root of 0 is 0. 4, 0, 1, 2, 3, 4. So we know it should look kind of something like that. So let's get a couple of these. So let's try 5. So 5 minus 4 is 1. Square root of 1 is 1. Bam. What else is easy? If we can make this a 4, so 8. So 8 minus 4 is 4. Square root of 4 is 2. So 8, 2. 4, 5, 6, 7, 8, 2. And it's basically going to look like that. It's parent function shifted to the right 4 spaces. Okay. All right, not too bad, not too bad. 33. Oh, now we're getting some trig functions. For each right triangle, find the missing side length. The hypotenuse is 4 inches long, so it's probably helpful to draw a picture here since they don't give us one. If the hypotenuse is 4 inches, how long is the side opposite a 40-degree angle? So let's just call one of these a 40-degree angle, and we need to know how long the opposite side is. So if we know opposite and hypotenuse, we're going to need sine. So sine 40 degrees equals opposite over hypotenuse. Getting our trusty calculator, we know that sine 40 degrees is 0.64278760 blah blah blah. We are then going to multiply that by 4 to solve for x. So let's just do that before we round to get a better answer. So we know that the length of x is going to be 2.57. We'll just go ahead and round that to the nearest hundredth. So 2.57 inches. 2.57 inches. And the answer sheet has 2.6 because they rounded to the nearest tenth. So that sounds good to me. 34. A 29-degree angle. Okay, so make a right triangle. We'll say this is 29. Has an adjacent leg 9 inches long. How long is the hypotenuse? Okay, so we know adjacent and we know hypotenuse. So that is cos. So we know that cosine 29 degrees equals adjacent 9 over hypotenuse x. Okay, this is a little different from the last one because the x is on the bottom. So before we even find cosine 29, we can solve for x. So we can multiply both sides. Whoops, excuse me. So we can multiply both sides by x first. So look, x, and then times x, and then divide by. So that gets rid of the x over here, and then we can divide by cosine 29 when we get it, which we don't have yet. So essentially, x is going to equal 9 over cosine 29 degrees once we figure that out. Okay, so cosine 29 degrees is 29 cosine. Here, since we have to do some calculation after the fact, let's just go ahead and round early. So 0.87. The less you round, the better your answer, but sometimes it's just easier here. So 9 over 0.87. And so 9 divided by 0.87 is, so this might be off a little bit rounding wise, so 10.34. The answer is 10.3, so we're good. So 10.34 inches. Sounds good to me. All right, I'm going to stop this video and we'll finish it up in the next one.